Okay, in this video we're going to finish up Chapter 15, Section 1 about central and inscribed angles, and here we have our warm-up. Over here we've got a circle cut into 4 slices, and they're going to ask us about some of the arcs. First thing, let's find this one last missing piece of the puzzle. If we add up the angles that we do have, it adds up to 260, and a full circle is 360. So if we subtract that, this slice is 100 degrees. All right, let's look at the first one, TQ. Here is TQ. The central angle for TQ is 120, so that means TQ is also a 120 degree arc, and it is a minor arc. Next, we have Q to R to T. So here's Q, and here's R, and we go all the way to T. So we could add up these 3 angles, or we could do 360 minus 120. Either way we do it, that's going to turn into a 240 degrees, and that is a major arc. Part C, T to Q to R. Well, here's T, and we're going to go to Q, and then we're going to go to R. And if we add up those 2 angles, they're going to add up to 180 degrees, and that is a semicircle. All right, now the bottom row, letter D is Q to S. So here's Q, and we're going to go to R, and then we're going to go to S. So if we add those together, that's going to be 160 degrees, and that is a minor arc. Okay, now TS, here's T, and if we go to S, that's one little arc. It's a minor arc, and the central angle is 80. So TS is also going to be 80 degrees. Last one here, R to S to T. Here's R, and we're going to go to S, and we're going to go to T. And if we add these angles up, we would get 180 degrees, and that makes this also a semicircle. Okay, warm-up complete. Let's look at some new stuff here. Before we dive into this, well, let me uncover this part here. Adjacent arcs are arcs of the same circle that share a common endpoint. We can add the measures of adjacent arcs. This is very similar to segment addition. So long ago we had segment AB, and if I put point C here, we could say segment AC plus segment CB adds up to the entire segment from A to B. The bridge, the shared point, was point C, so we could go right from endpoint A to the endpoint B. Something similar is going on here with arcs. So the arc addition postulate says the measure of an arc formed by 2 adjacent arcs is the sum of the measure of the 2 other arcs. So I rewrote it down here where I had a little more space. The measure of arc AB is equal to the measure of AD. I'll color that here in red. And then plus the measure of arc DB. So they share point D, so we can add those together and go right from endpoint A all the way to endpoint B, arc AB. Example 1, 2 circles with different radii have centers at A. Explain why the measure of arc EB is 40. So I'm going to hit this here in red. We want to show that that is equal to 40 degrees. And explain why. Well, if we look here, angle DAC is 40 degrees, and DAC would be vertical with angle EAB. Measure of angle EAB is equal to 40 degrees, and the reason is we have vertical angles. So this angle is 40 degrees. It is a central angle from the center of the circle, and that opens up to arc EB. That would mean the measure of arc EB is also 40 degrees because the central angle was 40 degrees. Central angle, 40 degrees. All right, part B. What is the measure of CDF? Well, here's C, and we go to D, and then we keep going until we hit F. So it's an entire circle except for this one slice. So we could do 360 minus 79 equals 281 degrees. And that is equal to the measure of arc CDF. So again, the explanation, or the how do you know, we would do a full circle minus arc FC. Full circle, minus FC, the arc. And FC, again, was our 79 degrees. Okay, we got some more fill in the blanks here. Prove the inscribed angle theorem. Two chords with a common endpoint form an inscribed angle. We saw that in the last video. The other endpoints and all points on the circle in between them form the intercepted arc. So in the picture here, it says angle ADB. Here's angle ADB. I'll hit it in red. Is the inscribed angle, and arc AB is the intercepted arc. Again, so here's arc AB. When those chords come out here, that's where they intercepted the circle. Okay, and some stuff about these inscribed angles. Inscribed angle theorem. The measure of an inscribed angle is equal to half the measure of the intercepted arc. And just to compare this to what we did yesterday, if I go from the center of the circle to A and to B, this arc AB and angle C would be exactly the same. If we want to take this back to angle D on the other side of the circle, we would just cut arc AB in half, half of AB. Now the second theorem, inscribed angle of a diameter, this is just a special case. Well, it says the endpoints of a diameter lie on the endpoints of an inscribed angle. If and only if the inscribed angle is a right angle. So I'm going to go back over to my picture, and here from A to B, I'm highlighting in blue that half of the circle. Half of a circle is 180 degrees. So when we take that back to the inscribed angle, it's going to be half of 180, or a 90-degree angle, a right angle. So segment AB is the diameter of the circle if and only if angle D is a right angle. Remember, the if and only if means we could read that in reverse. Angle D is a right angle if and only if AB is the diameter of the circle. Example 2. Jana creates a circular rainbow art piece by wrapping strings of various colors around pins that are tacked to a board. She needs to know the various angle measurements in order to design a fluid pattern. Part A, find the measure of arc BE. Well, here is arc BE, and across from it is a 30-degree angle. So remember, if we had the arc, we would cut that in half to get the angle. So now we're going to go in reverse. We've got the angle, so we're going to double it, and that means this arc is 60 degrees. Measure of arc BC is 60 degrees. Okay. Next, find the measure of angle ADE. Well, here's A, and if we go to D and then to E, we want this entire angle that I've hit in blue. We know that this chunk is 30, so what we need to do is find this red angle, ADC. And we can see here, arc AB is 70 degrees. So if we bring that in here to the inscribed angle, it's going to be half of 70, or 35. So we could write angle ADE is equal to 35 degrees plus our 30 degrees. So the measure of angle ADE is 65 degrees. Example 3. I'm going to underline in red, find the value of x, then find the measure of angle DCB. So when we look at these, we see we have an inscribed angle here, 9x minus 2 degrees, and we have the arc from B to D, 15x plus 20. So I'm going to write these in parenthesis, and for now, I'm going to set them equal to each other, which is not the case. It would be for a central angle. But I know if I have this arc, here's the arc, I could cut the arc in half, and that would equal the angle over here on the left side. And the opposite of multiplying this side by a half would be multiplying the other side by 2. So we could double the angle to have it equal the arc, or we could cut this arc in half to equal the angle. I think it's easier arithmetically to do it this way. because if we did a half over here, we would distribute in here and get a fraction or a decimal, and we can avoid those if we want. So let's solve. Distribute the 2. 18x minus 4 is equal to 15x plus 20. We want to solve and get x alone. So what I would do is subtract 15x from each side, and at the same time we can add 4 to each side. So here we're going to have 3x equals 24. Divide by 3, x equals 8. So that is the first part. Find the value of x. X is 8. Now we want to find the measure of angle DCB. DCB is in here. So what I could do is plug the 8 into this and find the arc and then cut that in half. Or I could just plug the 8 right in here. The angle BCD is 9 times x minus 2. And we figured out x is equal to 8. 9 times 8 is 72. 72 minus 2 is 70 degrees. There's our measure of angle DCB. Example 4. Circular garden divided into 3 sections with different colored flowers. The measure of BCD is 21. I'm going to draw my own picture. So here's B to C to D. This angle is 21 degrees. Now the next part here is pretty critical info. The measures of BC, I'm going to highlight that here in blue, and DC are equal. So what we could do is call CB equal to x, and DC would also be equal to x because we know they're the same length. So we need the measure of each arc. Well, we've got this 21 degree inscribed angle. If we take that out to the circle, that's going to be 42 degrees. So now we've got the entire circumference of the circle covered. So a full circle is 360 degrees. We could set that equal to x plus 42. X plus 42. All right, let's subtract. We'll combine these x's into a 2x, and then we'll subtract 42 from each side. So what would that be? 318. And now we're going to divide both sides by 2. So x is equal to 159 degrees. So it does tell us to find the measure of each arc. Well, we've got arc CB, we've got arc BD, and we've got arc CD. Well, CD and CB are both 159 degrees. And then we already found BD up here. That was 42 degrees. All right, excellent. That was the last example, so good time to pause the video, try these practice problems, and then fire the video back up and see how you did. Okay, here in the first one, a circle is A, EAC is 31, so E to A to C. This little angle in here is 31 degrees. Find each measure. All right, well, let's go back to the circle. If this angle in the circle is 31, that means EC is also 31 degrees, and that happens to be letter A here. What is the measure of arc EC? It's the same as the central angle, 31 degrees. Okay. Up next, part B, measure of angle BAC. Well, here's B to A to C, so we're looking for this angle. BE is the diameter, so that would be half of a circle, and we already have this 31 degrees taken up, so angle BAC is 180 minus 31, or 149 degrees. I'm going to mark that on my circle with blue ink. That 149 degrees. And now, BAC, the angle is 149 degrees, and now it asks for arc BC. Well, BC and angle BAC are going to be the same. A central angle and its intercepted arc are equal, so that's also 149 degrees. And now, last part D, find the measure of BDC. So if I use black ink, make this real thick, B to D to C, this angle opens up and intercepts the blue arc. We already know the blue arc is 149 degrees, and if we're going to take that back to the inscribed angle, we're just going to cut it in half. Half of 149 is 74.5 degrees. Up next, in each diagram below, all inscribed angles are congruent. Find the measure of an inscribed angle. So if we look at this, we've got the points where that design touches the circle. Let's see how many different arcs we have. I'm going to mark them off. 1, 2, 3, 4, 5, 6, 7. So the full 360-degree circle has been divided into 7 equal arcs. Those are each about 51.4 degrees. Now I'm going to switch to blue ink. So let's look at this arc right here I'm hitting in blue. If we're going to take that back to the inscribed angle up here, it would be half of that. So we're going to cut that in half and get about 25.7 degrees. All right, now the letter B should be almost the same thing, but different number. How many arcs over here? 1, 2, 3, 4, 5, 6, 7, 8, 9. So we do 360 divided by 9. So each of the arcs is 40 degrees. And again, to take that 40-degree arc back to the inscribed angle, we just chop it in half, 20 degrees on the nose. Next, find the value of x. I'm just going to make this a little bit bigger. Okay, so we know this arc, if we chop it in half, it'll take us back to the angle. So I could write the 14x plus 28. I could set it equal to 49. And what I could do is either distribute a 1/2 here, or on the other hand, I could just multiply the other side by 2. I think in this case, I will distribute the half over here because both of these numbers are even. Half of 14x is 7x. Half of 28 is 14. And that's equal to 49. And then we're going to subtract 14. 7x equals 35. Divide both sides by 7. X is equal to 5. All right. Number 4 here, we just got parts A, B, C, D. I think there's an E and F on the next slide. Let's see, find the measure of each indicated arc or angle. Here we want angle H to G to F in here. We've got a 90-degree arc, so we will cut that in half. The angle is 45 degrees. Here we're going to go in the opposite direction. We have the angle. We want to take that to the arc. So we're going to take the 38-degree angle, and we're going to multiply it by 2. So that would be 76 degrees. This part C here is the one that most people found confusing in class. I'm going to highlight with the black ink. Here, the 72-degree angle goes out here and intercepts this yellow arc. So we could multiply the 72 by 2 and get 144. And now we might notice that angle X opens up. I'll use red ink. It also intercepts at Z and also here at W. So it's intercepting the same 144-degree arc. So if we go back to angle X, we would chop it in half. And angle X, just like Y, would also be 72 degrees. All right, let's see here in letter D, we've got most of the way around the circle. We've got 70 and 120. If we add those together, we get 190. If we subtract 190 from a full circle, that leaves 170 degrees for F to D. And they're asking us to find the measure of angle G. So we're going to cut that 170 in half, and we're going to get 85. Angle G is 85 degrees. All right. Ooh, this one looks fun. LN is the diameter, and this takes up 160 degrees. There's 180 degrees in half a circle. So this little chunk LM is 20 degrees. If we're going to take the arc back to the angle N, it's going to be half of 20. Angle N is 10 degrees. All right, last one here. It wants us to find arc WX, so I'm going to highlight that in red. We've got this YX is 110, and we've got our inscribed angle 75, so let's double that to go out to the circle's edge, so that's 150 degrees. So to find WX, we will take a full circle and subtract these two angles added together. That would be 260. So 360 minus 260, 100 degrees. Arc WX is 100 degrees. All right, last problem. Very similar to the last example. We've got an inscribed angle and an arc, and it just says to find the value of x. That's all we got to do. Why can't I make this bigger? Well, that's fine anyway. I'm just going to write these two as being equal to each other for now. 8x plus 10 is equal to 12x plus 40. So if we take this arc and chop it in half, we'll get the angle. So if we distribute a half here, which I don't mind doing because these are both even numbers, it'll work out nice. 8x plus 10 equals half of 12x is 6x, half of 40 is 20. Let's subtract 6x from each side. 8x minus 6x is 2x. And then we're going to subtract 10 from this side, subtract 10 from this side. 20 minus 10 is 10. Divide by 2, and we get x is equal to 5. All right, that's the end of the practice problems. That's the end of the video. I'll see you in class tomorrow.